All right, Pythagorean Theorem here, video 2. All right, so let's get some problems done. This says, to satisfy safety regulations, the distance from the wall to the base of a ladder should be at least 1/4 the length of the ladder. Did Drew set up the ladder correctly? This is very, very, very applicable, right? There are safety standards, right? When you get a job, you got to watch safety training, videos and stuff to make sure you're using ladder, safe, all that fun stuff. So, again, something you could be asked. So first and foremost, right, in order to determine this, we need to find the length of this ladder. They give us two measurements. They give us 2.5 here and 9 here. We're going to assume that the, what do we call this? The shelving is perpendicular to the ground. There's your right angle. And here's our right triangle. Excuse me. Let's call 2.5a. Let's call 9b. This ladder is represented by the hypotenuse c. We must find it using Pythagorean theorem. A squared plus b squared equals c squared. I'm going to do 2.5 squared plus 9 squared equals, and I guess I called this x, right? So equals x squared. We're going to plug this in all at once. So 2.5 squared plus 9 squared, that gets you 87.25. And then to solve this for x, you're going to take the square roots. And rounded to 2 decimals is 9.34. So that is in feet. So that's about how long this ladder is. It's about 9.5 foot, right? Okay. So now the question is, this length of A, is it at least 1/4 the length of your ladder, which is the hypotenuse C, right? Again, this is greater than or equal to. That is what at least means. At least means that's the minimum amount, but it could be more, right? At least, right? You don't want the ladder too close, or else it's going to tip back on you. You're going to fall over. So, okay. All right. So we're just going to plug in our numbers. So 2.5 is your A. Again, my writing. 2.5 is my A, and the question is that greater than or equal to 1/4 of 9.34? So when you do this, right, the left-hand side becomes, so 2.5 is greater than, the right-hand side is 2.335. 2.5 is greater than 2.335. So yes, he has done this well. He set the ladder up correctly. Good for him. All right, next question. It says the length of each crosspiece of a fence is 10 feet. Why would a rancher build his fence with the measurements shown? Right. So obviously, as a rancher, you would like your posts, right, these vertical posts, to be perpendicular with the ground. So if you put them 8 feet apart and you put them 6 feet high, and you measure or know that this diagonal piece is 10 feet, would that ensure that that's going to be a right angle? Well, here's where we're going to use Pythagorean theorem in the converse, right? We're going to see, is this formula satisfied for those three sides? Now, because 10 is the longest, we would have to try 10 as C. Again, A and B do not matter. So I'll let 8 be A and 6 be B. Again, it doesn't matter. And then 10 would have to be C. So the question is 8 squared plus 6 squared equal to 10 squared? Right, that's your question. So you just type the left side in, 8 squared plus 6 squared, that is 100. You type the right side in, 100, or 10 squared is 100, yes. Okay, so again, this means that this is a right triangle, and those vertical posts would make right angles with the ground. So what I would say is, I would say the vertical posts meet the ground. The vertical posts meet the ground at right angles. And again, in parentheses, I'll put the big boy word or big girl word, which is scribbled perpendicular. And there you go. Now, one thing to piggyback off of is this idea of called a Pythagorean triple. So a Pythagorean triple is a set of 3 non-zero whole numbers that satisfy Pythagorean theorem, right? So 6, 8, and 10 are a set of whole numbers that do satisfy Pythagorean theorem. And there's many more out there, right? Now, actually, if you divide those by 2, you get 3, 4, 5. 3, 4, 5 is one of the most famous Pythagorean triples. And again, as you can see, you can proportionate. You can multiply. It's a ratio. You can multiply all the numbers by the same number, and you get infinitely many Pythagorean triples. Okay, so just keep that in mind as you take further mathematics. Okay, so now I'm going to introduce you to what's called the 45-45-90 triangle. This is a special triangle. If you take pre-calculus, this is going to be a very good thing for you to remember. Okay, so the question is, in this 45-45-90 triangle, is there a special relationship between the lengths of AB and AC? Right? Okay, so here's what we're going to do. Right. We are going to talk about the properties of this right triangle. Then we're going to use Pythagorean theorem to prove the relationship. All right. So first things first. In a 45-45-90 triangle, even though only two of the side lengths or two of the angle measures are given, you should know that this is also 45 degrees, right? And again, the idea is 180 minus. And again, you add up 90 and 45 and subtract that from 180, right? And that's going to get you 45. So because these two angles are congruent, the legs are going to be congruent in this picture. So I'm going to call this L for leg, this L for leg, right? So a 45-45-90 triangle is an isosceles right triangle, okay? Which is nice because two of these sides are the same. So now the question is, what is this third side going to be? What is the hypotenuse going to be? Well, we're going to set a Pythagorean theorem. Okay, I'm going to do it in blue here. So a squared plus b squared equals c squared. Right, so your a and b are the legs, L and L. And your c is the hypotenuse, h. So we're going to do L squared plus L squared equals h squared. So L squared plus L squared is 2L squared. And now we're going to take the square root. Now when you do this, you can take the square root of L. The square root of L, the square root of L squared. The square root of L squared is L. But the square root of 2 must remain because it's not a perfect square. And then h comes out. And this is the main idea. That to find the length of your hypotenuse, you must take the length of your leg and multiply by the square root of 2. So in this picture here, if we try to bring it back to AB and AC, AB, the hypotenuse, is going to be AC times the square root of 2. Okay? So what is powerful about a special right triangle, like a 45-45-90 triangle, is the fact that you only need to know one side. If you know the leg, you can find the other leg and the hypotenuse. If you know the hypotenuse, you can find the other leg and the other leg. So unlike Pythagorean theorem, where you need two sides, 45-45-90, you only need one side, right? Special relationship. All right, so here is the formal introduction of a 45-45-90 triangle. So again, in this picture, you will see that your side lengths are S and S, your legs are S and S, right? And your hypotenuse is going to be S square root of 2. The length of the leg times the square root of 2. So the hypotenuse is the length of the leg times the square root of 2. Okay? So keep this stuff all in mind. This is something you should really memorize. You should have this picture in your brain, and on the day of the test, you should be able to write this on your piece of paper and have it there forever. Okay, so all right, we're going to stop there. I'm going to make the next video. The next video is going to introduce you to the 30-60-90, and then we'll do two problems involving these special triangles. All right, video 3 is coming up.